Well, if you guys are here, then I can only one thing, that it is time for
a physics break.
All right, guys. Well, so we have been talking a lot about solar energy in class, and obviously I was just in the middle of a pretty big concert, and the one thing I can think about that these two things have in common is light. So on today's physics break, we're going to be talking all about light. And in particular, we're going to be thinking about how light disperses. Now, as an astronomer, this is the most important thing for me as an observer, because what I'm interested in when I take astronomical photos is light. Light from stars, light from planets, light from other celestial objects. And knowing how that light travels, how its brightness decreases over distance, is vital for figuring out what these things are like. So light is a huge deal for me as an astronomer, but it's also a huge deal for all of us. My stage guy, Benny's got to put up my light somehow, and he's got to know if he puts a light 10 feet up there, how much ground's it going to cover? How does light disperse? And that is what we're going to be talking about today. Whew. All right, well, now that my makeup is all washed off and the concert is finished, we can get back to the lab and do some physics. And today, as promised, we're going to be looking at light. So I have already set up our experimental setup for today. I have a light bulb at one end, and I have a tape measure that is attached over at the other end. So I'll be able to measure the distance from this light bulb that I am at. Now, you might want a friend for this physics break because it can be a little tricky to do all this on your own. So you might want to have someone else help out by holding a tape measure by a lamp. Now, I'm going to try this a couple of ways, because this is an experiment that really depends on the sensitivity of the sensors we'll be using. So I'll try it with a shade, without a shade, I'll try it with ambient light, I'll come back and try it at nighttime, see if that helps as well, to try and get the best measurement I can. And what I'm looking for is to figure out how the brightness of light changes as you move away from a light source. So for my next concert, for example, I could go back in and I could say, all right, well, I want the lights to be this bright, so I know how far away from me they need to be in order to get that brightness. So how does the brightness of light change as we move further and further away from a light source? Let's figure that out. To do this, we're going to be using a new app. That's right, we can't use Firefox because Apple's iPhones do not allow you to access your light sensitivity sensor's raw data. However, we can use a little digital magic to get a good proxy. So we're going to be using a new app called Science Journal. It's an app from Google that's going to tap into our phone's light sensor and do some digital processing to get us a nice proxy of that measurement. It's going to be in EVs. So I'm going to go ahead and record my screen so you guys can see exactly what I'm doing and follow along. So I'm just going to open up the Science Journal app, and you can see here that there's sort of a nice home screen, and on the bottom right hand corner there's a plus. We're going to hit that, and now we have a new experiment. I'll go ahead and call this light versus distance. Awesome. Now Science Journal is awesome because you can add photos, measurements, all kinds of stuff, and it has a wide array of sensors as well. So I don't want an observation, but I do want a sensor. So I just click on accelerometer, and now instead of the accelerometer, let's see here, brightness in EVs. So you can see here it's reading the ambient light, and it's reading it from the front of my camera. So it's reading it from my front camera, not my back camera. So it's going to be a little bit tricky to try and get my measurements here because we have to be like having the phone face the light source and also doing the thing, but we'll see what we can do. So I'm going to turn on my lamp, and immediately the EV number shoots right up because we are really have a nice bright signal here. And you can see that if I hold it in one spot, it stays pretty consistent because the light hitting the sensor is the same regardless of how far from the light source we are. So what I'm going to do now, I'm going to start about 4 inches from my sensor, and I'm going to use this bottom left-hand button to take a picture. And that will record that value. I'm going to jump back 3 inches, do it again. Jump back 3 inches, do it again. 3 more inches, and I'm just going to keep doing this until I have a bunch of data read from this sensor. Now, like I said, I might need to make the room darker. I'm going to have to try this a couple of different ways to really see what happens, because we've got a lot of ambient light coming from this room as well. So we'll go ahead and call that trial 1. Now, I'm going to darken the room around me a little bit and do another trial and see what my information looks like when I don't have so much natural light coming in from all the windows in this room. Okay, you guys might not be able to tell, but it is actually significantly darker now, believe it or not, because I have closed the shades on my windows. So let's open back up our Science Journal app. We'll go ahead and let's actually rename this one Light versus Distance 1, and we'll do a new one in this new environment. All right, so now that we have our new experiment set up, let's take a look and let's just see what the ambient light looks like around here. Oh, so it's way darker. It's like in the negatives, so we're getting a very different ambient light reading here than we were earlier. So very, very dark here. And when I turn on my lamp, there's that nice spike there. So we are already getting different reading. I actually could just see my screen get brighter when I turned the lamp on, which is pretty cool. So our sensor is working and reading properly. So let's try this experiment again. We'll start 3 inches and take that reading. And then we'll just go back 3 inches at a time until we have a nice set of data. So that is it. That is my second set of data. So now I have 2 sets of data, one with lots of ambient light, one with not a lot of ambient light, and we can take those 2 data sets and see what they tell us. Now, if they're both noisy, if I'm not getting much of a result, I might need to redo this whole thing one more time in the dark at night. So let's see what our results look like, and we'll go from there. See you guys in the analysis lab. Alrighty guys, so you can see here that I am on our virtual laboratory, aka Google Sheets, and I've just created a brand new sheet and went ahead and labeled it Science Journal Light Data so I know exactly what I'm working with. Now what I'm going to do here is I'm actually going to put in my data by hand because I only had about 20 data points and I couldn't find a great way to export those in a way that made sense. So in this case, I went ahead and looked at both my data sets, and the less ambient light, the better. So I'm going to use that second trial we just saw and input my data here. Now, for the first part of this physics break, we're just trying to get our data plotted. We don't want to do any hardcore analysis on it yet because we want to take a look at everyone's data together first. So all you need to do for this part is just get your data plotted, and then we can go from there together in class on Monday. So what I'm going to do is I'm just going to go ahead and I'm going to label my 2 columns, which in this case are distance from my lamp, and this is in inches, and brightness, which again is in that weird EV measurement that Google gives us in the Science Journal app. And then I started that second trial at 3 inches, and then I just sort of took measurements every 3 inches after that. So my previous measurement plus 3 inches, and that is going to be all of my measurements up to 60, so that's too many. So 60 inches all set there. And now I'm just going to go through and put all my measurements in by hand. Okay, and one last thing I'm going to do is just make a note for myself about the ambient light. Ambient light? All right, and the ambient light in my case was negative for EV. So just that I have that in case I need it when we do our analysis. Last step, I'm just going to select my data, and I'm going to make a nice scatter plot. Just going to change this to scatter. Voila. So I'll go ahead and make this a little bit easier to see for myself. So I'm just going to come over here. Let's make our vertical axis start at about 3. So let's do a minimum of 3 and a maximum of 5. All right, and now we have a beautiful chart of brightness versus distance from my Google Science Journal light sensor. And I can take a look at this and start to think about what kind of function might fit this graph, and therefore how distance and brightness are related. And that's all there is to it. Okay, so I have plotted all my data points and they look good. It looks like I'm going to have some actual usable real data, and that's fantastic. But I only have 20 data points. This isn't like the experiments we took with acceleration data or the experiments we did in class where we're taking data every half second or every second and we have hundreds of reliable data points. I only have 20 points from that 5-foot measurement. However, there is a good way to be able to see if my results are kind of accurate, and that's to try them against other trials. So PhysCalc, what I need from all of you now is to replicate my experiment. Do it for yourself. Take all of your data, make your own spreadsheets, and maybe we'll be able to see a little bit better the pattern that our data is following. What kind of function could we fit to our data and make it look good? And then that will tell us how light changes in brightness as we get further away from a source. How are the distance you are from a light source and the brightness of said source related? We could try and figure it out from my data, but we can figure it out better from all of our data. So I'll see you all on Monday, data in hand, in order to tackle this question once and for all about how light changes as we move away from a source. Until then, PhysCalc.